Okay, so we can just start by putting the forces onto our diagram. So we know that A is 3 kilograms, so there's a downward force acting on A of 3G. There's an upward force there, which we're going to call the tension in A. We'll call that TA. In B we know 7 kilograms, so that's got a force of 7G. And an upward force we're going to call the tension in this string. We'll call it TB. This one here we know has got a downward force to 4 kilograms, so it's got a downward force of 4G. It's pulled to the left with the tension from A, it's pulled to the right from the tension in B. But be careful, it's a rough table, and we know that the coefficient of friction is 0.65, so we're also going to have friction at play here. Well, because this is heavier than this one, we know that the system's going to move to the right, so we can put our direction of acceleration. Always helpful to have the direction of acceleration for all of our objects, because otherwise we tend to get confused. So it's going to be accelerating in a clockwise direction. So if it's accelerating in a clockwise direction, we know that the friction is going to be going to the left. So I'm just going to put that out here. That's my friction, and I know that my friction is going to equal 0.65 times 4G. 0.65 times 4G gives me an answer of 25.48. So there's another force there, don't forget your 25.48 newtons. Okay, so we've got all of our forces then, and so we should end up with 3 separate equations of motion. So let's start with A. Equation of motion for A is the tension in A minus 3G is equal to the mass times the acceleration, where the mass is 3, equals 3A. For B, I've got the tension in B minus the tension in A minus 25.48 newtons for the friction is equal to the mass, 4, times the acceleration. Sorry, this is C, my bad. For particle B, I've got 7G minus TB is equal to 7A. So you've got 3 equations, which makes it slightly more complicated than normal. The easiest way to do this is going to be to substitute in, make TB the subject of this one, make TA the subject of this one, and substitute into the second equation. So that's what we're going to do. So I've got TB minus TA. Well, TB is going to be 7G minus 7A. So I'm going to do substituting into equation 2. We've got 7G minus 7A, that's my tension in B, minus the tension in A. Rearranging that will give you 3A plus 3G, minus 25.48 newtons equals 4A. Okay, so let's just look at our G's. So we've got 7G minus 3G, which gives me 4G. I've got minus 7A minus 3A minus 10A. 4G minus 10A minus 25.48 equals 4A. Bring the A to the other side. 4 times 9.8 is 39.6. Minus 25.48 equals 14A. 39.6 minus 25.48 gives me 14.12. And I've made a mistake. Sorry, I've spotted my error. This should be 39.2, not 39.6. 39.2 minus 25.48 gives me 13.72. Divide that by 14, and it gives you A equals 0.98 meters per second squared. So substituting it back into equation 1 gives you TA equals 3a plus 3g, which is 3 times 9.8, 0.98, plus 3 times 9.8, gives you an answer of 32.34. And here we've got TB equals 7g minus 7a, which is 7 times 9.8 minus 7 times 0.98, which gives you 61.74 newtons.